Hello dear, good morning. And you have started watching videos on fuzzy logic. Um, you know, situation is very critical. Our country is under the severe grip of coronavirus pandemic, and every day many people are suffering. Okay. So we need to be very careful. You see, I have wear two masks till you get your real vaccine. This is actually your vaccine. So two masks I have wear. I'm coming from outside. So please, you also obey the same rule. Okay? So we together will have to defeat the coronavirus. So today is April 29th, 2021, and we are going to study a fuzzy inference system. And in that context, we'll study what is fuzzy logic and what is fuzzy thinking. Then we'll talk about fuzzy set, because fuzzy thinking has to be translated in silico. For that, we need to write in the form of a set. Okay, and then we'll also learn what is linguistic variables and hedges. Okay, what do you mean by that? Then how to operate with the fuzzy set, we should also learn, and then we'll also learn how to formulate fuzzy rules and how to design a fuzzy inference system. And we'll conclude by actually designing a fuzzy inference system and telling you about many applications which fuzzy logic has in different fields. So you see, fuzzy logic actually is a tool which is coming. If you remember, we just at the beginning we draw some sketches like this. This is our AI, sorry, and this is our machine learning. This is our deep learning, machine learning, AI. So fuzzy logic actually is a tool in this group, artificial intelligence tool. Actually, if you have seen in the history, we have studied that expert system demonstrated for the first time perhaps the application potential in solving real world problems, right? And when in the expert system you incorporate fuzzy logic, the expressive power of the expert system becomes bigger. Means the expert system will be able to give you the solution of the problem more accurately if you design expert system using fuzzy logic. Why it is so? Because you see, in our real world, many things are fuzzy. Means when I say yesterday temperature was very high, you see, very high, and whoever is around Allahabad and your institute, and this is April, end of April, everybody will know that okay, high means or something like 40 degrees centigrade. Okay, or if I tell in the January, okay, that temperature is oh, it's very cold, temperature is too low, you immediately know it must be 1-2 degrees centigrade, right? So telling high, low in a particular context, in a particular area, convey a lot of precise information. On the other hand, if say, for example, somewhere in Seattle, in United States, you are in winter, okay, if I tell you during Christmas that, oh, it's very cold, so immediately you will know perhaps the temperature has gone down to minus 3, 2-3 degrees centigrade. Or if it is in somewhere in Canada, Newfoundland, temperature has gone to minus 25 degree. The meaning is a low temperature, you see. So low, high, average, okay, very high. All these linguistic uh, messages carry very precise thing, provided we can formulate it properly. Okay, so that's the beauty, and many times the fuzzy inferencing clearly helps. Say you are entering somewhere, okay, and in some building, and some construction was going on, and say somebody told you there is a hammer which is falling, okay. So what you will do? Hammer is falling with a very high speed, right? What you will do? Will you calculate what is the mass of the hammer and what is the initial speed and how long it is going to take to reach to your head? No, of course, right? Oh, hammer is falling, flee, run away. Okay, so this is fuzzy behavior you are exhibiting, which is very, very practical, which is very, very useful, right? So that's fuzzy logic is, and that's fuzzy thinking is, right? So it can actually help you in solving many, many problem, real world problem, which cannot be solved otherwise so accurately. Okay, so it has tremendous power, expressive power, which we are going to study in a couple of lectures. Okay, so see, we have say we are solving some problem in agricultural area. For example, if last 10 years um, crop um, production is known, and you can also get the data that what was it average temperature, how much rain was there, okay, all kind of thing, whether there was any storm or not, okay, and the village people who may not be having degree and all kind of thing, but those old people, he's working so many years in the in growing crop. Okay, he knows much better that what is going to happen to the particular crop yield of the crop in the next year. Okay, so or this is an example I gave. Many such examples could be there. A for example, medical personnel who is very experienced, right? Maybe a sister or nurse, right? Who is very experienced in handling um, or giving service to the sick people. She can have some idea about what is going to happen for this patient, okay, and what way the management should be done, okay. So, you see, this expert knowledge are very, very important, as you know. But they cannot express. For example, they do not know how to do programming and all kind of things, how to design an expert system. But they have knowledge which they can express in terms of linguistic form. Okay, that okay, it looks like this will be very good crop next year, or it looks like that C will have problem in fighting this illness, so we'll have to do this kind of thing. So this kind of linguistic wisdom of people who are working in those particular area can be captured, uh, and they're all they're thinking. You see, mostly because nature is such that thinking is fuzzy. Okay, so fuzzy logic. That's why you see fuzzy logic. You must understand that it is not the logic which is fuzzy, but we are trying to capture the fuzziness or vagueness of the environment using this logic. So it's very sophisticated logic, okay? Because environment is full of fuzzy and ambiguous um, communication variables, okay? Once my daughter, she was at the time um, 5 years old, 6 years old, right? And I was driving a car, and I was having some hard time to actually park the car properly. So what she was standing outside, she told Dad, drive here and right. This is very vague. Otherwise, but I could understand what is the meaning of that, and I could park my car perfectly in the car. So I'm giving some example. Giving the kids knowledge, my brain captured, okay, through fuzzy thinking. And These are all full of such good problem solving capability fuzzy logic has. Okay, though you see, on the contrary, so far you have seen everything in actually machine learning. You have studied that you have data, past data, level data, and then you are trying to see what is the pattern hidden in the data, right? And mostly we are using bi-valued logic, okay, or using very little logic at all. Okay, you are trying to capture the pattern. But you see, say for the example that in case of neural network, right? If somehow we could know that during in the hidden layer how the weight are actually being adjusted, uh, can we put some logic over there so that the logic with which the weight are being adjusted will be known to me, and so that in that way I can make my computation uh, much more faster. All kind of things are possibility. So bivalued logic is, you know, that it has limited capability of expressing. For example, I will show you afterwards that bivalued logic can only tell you yes or no. For example, I have some uh, height. Okay, so I have given you that I am 6 feet 1 inch, for example. Right? So, and you decide that okay, 6 foot means he will be categorized as tall. And suppose you are using bi-value logic, tall or not tall, tall or not tall, right? So if my height is 6.1, I'll be classified as tall. But using this bi-value logic, if somebody has 5.9, 5 feet 9 inch, she or he is also tall, but in your bi-value logic, she will be considered as not tall. So bi-value logic has lots of limitation in terms of expressing the real world problem. So that's why you see way back in 1930, Jan Likoshevich, a Polish philosopher who thought of multi-valued logic, which is afterwards known as fuzzy logic. So fuzzy logic is essentially a multi-valued logic. Okay, and later in 1937, Max Black published a paper. So this is some of the history uh, called "Vagueness and Exercise of Logical Analysis." Vagueness and exercise in logical analysis. So what role vagueness plays in analyzing logically the things? As I gave the example, that come straight, try right, straight right. She did not specify that what is the scale and how much angle I'll have to turn right. But these are vague communication transpiring many things. If we could capture those things in the form of a logic, then perhaps we could solve many problems. That was the idea of multi-valued logic. Okay. So you see, so you see, 30s, 37, and then of course 1965. You see, in those days, the computation power was of course very limited, and then since fuzzy word was attached by Jan Likoshevich, fuzzy logic, he wanted to communicate with multi-valued logic, mean multi-valued logic. People thought the logic is fuzzy. Okay, so people did not put a lot of attention to this great uh, artificial intelligence tool, which solved so many problems nowadays in consumer product. Hardly there will be any product which doesn't have fuzzy chip, just like your washing machine, camera, television, all kind of things where fuzzy chip is there, fuzzy logic is being translated into practical applications. That is because primarily in 1965, Lotfi Zadeh is a great scientist, mathematician, published his famous paper, Fuzzy Set. Okay, and he actually extended the work on possibility theory into a formal system of mathematical logic. So that's the great contribution which he did, and then many Japanese people, actually Shigono and many others, they actually used the idea, great idea of fuzzy logic in the form of producing some product. You see, this is exactly the pictorial representation that how a bivalent logic has a limitation and how multivalent logic are far better than bivalent logic. I will give a concrete example. Say, I am using bivalent logic to distinguish between day and night. So you will tell that, okay, the white one is day and night. The dark part is actually night. So one day I have divided into two in Boolean logic or bivalent logic. So it can represent day and night. Fair enough. But how about twilight? How about dawn? How you can use the same logic in describing twilight? That is also considered amount of duration of time, right? Or how about in the morning? It is dawn before morning. Bivalent logic will fail to represent them. But that's why, you see, multivalent logic, you see, is a continuum, right? You see, the one day is now divided into small continuous values. So this value shows you that if this is representing day, how much day? Gradually day is becoming dark. So here it is night, here it is day, and in between maybe this is twilight, and this is dawn. So every possibility is there. You can express those aspects also using multivalent logic. You understand? No? So it is powerful logic, right? So now again I am giving an example that I would like to characterize length or height of a person using these values, right? Say I measure the height. So these are my subjects. Aditya 6 feet 7 inch. Okay. Chris says, suppose Chris means bivalent logic. I am calling this height as tall. So it will be classified. It will be one. On the other hand, somebody is using fuzzy with the help of degree of membership. Okay, I'll explain that. Okay, so here let me explain. So every entity, every part here has a degree of membership. Say if it is perfectly day, so degree of membership of that particular element, that is perfect day, will have maximum membership value in the category of day. On the other hand, if it is perfectly night, so this night will have maximum value, membership value in the category of night. But this also will have some value, so this is twilight, will also some value to be characterized as day. So this will belong to day with some value, membership value, say it's not day, it's twilight. So it is membership value in the class of day is low, but even then it has some value, say 0.4. Okay? And in the category of say darkness or night, it has some value of 0.6. The way you become closer to the night. Twilight, if it is closer to daytime, for example, in our country, normally 7:30 in summer is night, right? So how about 5? It is twilight, but it is closer to day. So it will have high membership value towards day and low membership value towards because it is twilight. So low membership value to the category class of darkness or night. On the other hand, 7:20 will have low. 7:20 will have very high membership value in the class of night, and it will have low membership value in the category of day. So that's the fuzzy way of thinking, because this is very democratic. So you are not uh, classifying an entity with yes or no. You are giving a continuum value. By that, doing that, you are giving a possibility that this could be day also, this could be night also, having some continuum value. And it turns out that it has enormous expression power in terms of precision for solving a real world problem. Okay, so I am trying to again tell you example, right? This is say tallness. I am characterizing attribute tallness. Okay, so these are my height. So this will be in bi-valued logic. So Chris or bi-valued logic. So I am using fuzzy logic. Okay, so this will have say really tall. So this also is tall. This is also tall. 6 feet also tall, and this is also tall. At the moment it is 5 feet 2 inch, then it is not tall, dwarf. Okay, say short. There is no in between. But here you see continuum, right? One. I can design a membership value. Okay, so tallness or shortness can be characterized with the membership value. If the height of a person is like this, 6 feet 7 inches, definitely it will have 1. Okay, but how about 6 feet 3 inches? It will have the category of tall, 0.97, very high value, very highly unlikely that she is tall. But on the other hand, some value is there that okay, she is also categorized in the short. Okay, so continuously you see this is called continuum. I can put those values between short and tall in fuzzy logic in a continuous way, but on the bi-value logic it is yes no way. Okay, so this is actually has limited um, capability of expressing real world scenario, isn't it? Because you see, if you are calling 6 feet 5 feet 6 inches as tall, you cannot call 5 feet 5 inches as dwarf, or 5 feet 2 inches as dwarf. So that is the problem. Okay? So that problem has been addressed here in fuzzy logic. More, I will give you this whatever I told in a pictorial way. That we normally say in this axis we denote the degree of membership value. Okay, and this is the attribute means height. I am measuring height, for example. So in centimeter, okay, 150 centimeter up to 180 centimeter, for example. This is an example. I am calling everything as short, but as soon as it becomes 181, I am measuring by a scale, right, with a sensor. And as soon as it is scaling 181, you are telling it tall, characterizing the person as tall. But 180 is short, 179 is short, which is wrong, very much wrong. Okay. On the other hand, this is a fuzzy membership function. We call this membership function, which characterize in a continuous way, okay, the attribute of tallness. For example, here you see that 160 centimeter is also tall, but membership value is low. 170 is tall with this membership value. 180 is tall with this membership value. 179 is also tall with this membership value, right? So 190 is tall with this very high membership value. So this is a membership function in fuzzy logic. We try to capture with a continuum, we can characterize the attribute of tallness. This is much more practical than this. Now, how to capture that information which I told you earlier, right? To capture that information, we can construct fuzzy set. What is fuzzy set? Fuzzy set has some boundary. Okay, so this is a fuzzy set. it's a boundary, had some boundary that is 150 centimeters to 210 centimeters. It's bounded within this centimeter. Okay, and each element, and also in a this is a jargon term, we call it universe of discourse. Say I am trying to characterize tall person's height, tallness. So what I need to do, if I would like to create fuzzy set to capture this attribute, I will have to first create a universe of discourse. That means from what to what I will call person as tall. So that's called universe of discourse. Here, say 150, in this example, 120, 110. And then every element in this universe of discourse has some membership value in the category of tall. Okay, and that membership value is given by a function like this. So this function can also be like this. Okay, or this function could be also like this. So it's up to actually expert, or maybe you can collect data and your past experience, you draw a line. Okay, a function. So function need to be designed. But basically, how to create fuzzy set? Give a membership value. Say, I am creating a set now, fuzzy set. So 150 with membership value in the category of tall is 0. Then, 152 with the membership value of 0.1, or 155 with the membership value of 0.155. So this is the membership value. Okay, say 0.15, so far and so forth. So say 170, it will have a membership value. You just scale it up from there. So I am writing the element in the fuzzy set, and this is a tuple slash its membership value. So this is my elements in the fuzzy set. So attributes coupled with its membership value. I can thus create a set with as many number of elements as I want. More elements you put, more precise inference you can draw, but more computation you need to do. So there is no freelance again. Okay, so this is actually concept of how to design fuzzy set. So formally we can just tell you that in F is the inverse of discourse, its element to be denoted as X. In classical set theory or crisp set, okay, X is defined like that. The defined like a function. F A is the called the characteristic function of A. Crisp set A function has two values only, 0 and 1, where the function characteristic function A elements of discourse, universe of discourse X has only two values, either 0 or 1. That means whether either the particular element belong to a class or it does not belong to a class, like this. Okay, so either this element belong to a class tall. If this is the class of tall, so its value will be 0. Its value will be 0. All this value will be 0. Membership value will be 0. On the other hand, just here somebody membership value will be 1, and all others membership value will be 1. So 0 and 1, 0 and 1. But here, you see, it's a continuum, more realistic. Okay, so in this way, you can create fuzzy set, which is defined here. Okay, so it's a membership function. This is normally this kind of terminology is used in most of the cases. So we are also using similar kind of thing. So a fuzzy set A of universe of discourse capital X is defined by a function with its membership value mu A X, called membership function of set A. Okay, and the value of the membership function will be bounded within the universe of discourse. Here it is 0 to 1, and in our earlier example it is between 150 and 210, whatever, right? So this is bounded. This is called universe of discourse, where the value of the a function, membership function will be 1 if x is totally belong to a set A, will be 0 if it is not belong to A. However, for all intermediate x, x will be partially belonging to that class. Okay, so just whatever pictorially we have written here, we are telling. So this definitely does not belong to tall category. This does not belong to the tall category, but these all partially belong to the tall category. Okay? So this is what it is telling. Okay? So we have defined what fuzzy thinking is all about. It has much more strong expressive power, and hence it can solve many real world problems more effectively than our bivariate logic. And you know now, Jan Lukasiewicz in 1930s just introduced that great idea, which in 1965 Jadhe, a great scientist, actually brought this fuzzy logic into the full form, full-blown form, where it is used in many applications in making intelligent decision, solving many complicated problems where you cannot easily make model other based on mathematics or some other tools. Those complicated problems can very effectively solve using fuzzy logic. And in that context, you have learned that how fuzzy set can be defined, and then we will further study that once the set is there, how to represent them in the computer, and then how to manipulate the fuzzy set to crank out better inference. And for doing that, you need to know a little bit about um, fuzzy arithmetic, that is fuzzy addition, subtraction, multiplication. Specifically, we'll talk more on fuzzy addition in my next class. Till then, stay safe and wear mask, double mask, because you need to protect yourself from this dangerous coronavirus. So stay safe. Have a nice day. Bye bye.